Hello student, this video lecture is prepared for particulate technology subject, and I will discuss the unit number 6, that is known as the mixing. So in this unit, these are the contents of the unit number 6. Out of these contents, concept of mixing homogeneous heterogeneous mixtures, importance of mixing and agitation, mixing liquids with liquid, and construction of flow pattern of impellers, that is propeller, turbine and pedals. So these points we will discuss in today's lecture. So what is mixing? Mixing is a process in which at least two separate material. So this material may be present in a same phase or different phase, maybe liquid or gas, liquid, solid, liquid, like that, are taken and force them to randomly distributed through one another by some mechanical means. Or sometimes the term mixing implies taking at least two separate phases and causing them to distribute randomly through one another. So this may be mixing may be taken in a different phases like liquid, solid or gases. That means sometimes there are two same phases may be involved, sometimes there are one phase may be involved of two different liquids, like that. Or sometimes maybe some solid with liquid. So there are a lot of combinations for mixing. So generally mixtures are classified as a homogeneous mixtures and heterogeneous mixtures. So homogeneous mixtures is nothing but the components in the mixture present in a single phase. That means if we take the liquid mixture of methanol and water, so here both methanol and water is a liquid, so it is called a homogeneous. Or if we take the gases like carbon dioxide, nitrogen and oxygen, so that is called a homogeneous mixtures. So in homogeneous mixtures, the components are present in a single phase, that means liquid or gas or solid, maybe solid. Then there is another type that is known as the heterogeneous mixtures. So in these mixtures, the components are present in a distinct phase or separate phase. So that mixture is called a heterogeneous mixture. That means, for example, if we take the liquid mixture of benzene and water, so it will form the heterogeneous mixture, because these two mixtures are immiscible liquid phases. That means these two liquids does not mix with each other, so it is also called heterogeneous mixture. Or you can add liquid and solid, that is called a heterogeneous mixture, or gas and liquid. So when the components are present in a different phase, that is called a heterogeneous mixture. When the components are present in a single phase or in a same phase, that is called a homogeneous mixtures. Then why the mixing or agitation is carried out? Mixing is also called as agitation. So why this mixing or agitation is carried out in a chemical industry or petrochemical industry? So blending the miscible liquids. Blending means, again, it is called a mixing. Mixing of the miscible liquids. That means two liquids which is completely soluble to each other, that is called a miscible liquid. Dispersing gas in the liquid. That means we have to suspend a gas in a liquid. At that time we can use the mixing operation. Suspending or dispersing the lighter solid particles in the liquid to form uniformity required for promoting mass and assisting chemical reactions. That means sometimes in case of transfer of the mass or in chemical reaction, we have to suspend a lighter solid particles in a liquid. At that time also you can use the mixing operation. Dispersing or contacting immiscible liquids. Immiscible liquid means liquids like benzene plus water. So that mixture is called immiscible. So heterogeneous mixtures also mix with the mixing or agitation. Then promoting the heat transfer between liquid in the container and in a coil or jacket surrounding the container. That means sometimes if you want the transfer of heat in the liquid, at that time also the mixing or agitation may be carried out in a petrochemical industry. So these are the objective of the mixing. So first we discuss liquid mixing of liquid with liquids. So in this case, this mixing is carried out in the tank. So that tank is called a agitated vessel. So this tank is nothing but it is a vertical vessel fitted with the agitator. That means agitator is placed in this agitator vessel, and the height of the vessel is having the size 1.5 to 2 times the diameter of the impeller. So this is called the impeller or agitator. Then this height is 1.5 to 2 times greater than the diameter of this impeller. Okay, and this vessel is having agitator. So this is called a agitator. This is called a agitator. So this agitator is used for mixing purpose, and you have to add the liquid from here. Okay, so and here also. So you have to mix this liquid and you have to take out the liquid from this outlet valve or discharge provided at the bottom. So here the actual figure or actual photo of this agitated vessel. So this is called a agitator. So this agitator is driven by the electric motor. So here electric motor is provided for rotating the agitator, and these are the nozzles. So this is called a nozzles. That means for feeding the liquids or taken out the liquid from this tank. So generally the mixing of the liquid is carried out in this tank. So it is called a agitated vessel. And these baffles are provided. This is called a baffles. The baffles is nothing but rectangular strips or plates is provided in the tank to reduce the vortex. So this point I will discuss in next lecture. And this is the thermowell. So thermowell is provided for the temperature measurement. So temperature measurement device is inserted here and the temperature is measured. So this is called a agitated vessel, and it is used for the mixing of the liquid with liquid. That means if we are having one liquid and another liquid, then we have to mix that liquid. So for that purpose we are using the equipment that is called a agitated vessel. So there are two types of impeller. So impeller is nothing but the agitators. So there are two types: axial flow impellers and radial flow impellers. So what is meant by axial flow impellers? So these impellers make the angle less than 90 degree with the shaft. Okay, so this is the shaft and this is the impeller. So these impellers make the angle less than the 90 degree with the shaft, and they generate the flow current. So this is called a flow current. So this flow current is parallel to the axis of the shaft. So if we look at this figure, so this is the axial flow impellers. So these flow currents is produced which is parallel to the shaft. So this is this current produced parallel to the shaft. So this is called axial flow impellers. And another type is known as the radial flow impellers. So radial flow impellers is nothing but it produces the flow current perpendicular to the shaft. So they produce the flow current in this direction. That means perpendicular. Okay. So according to these types, there are three subtypes of a impellers, means classified as a propeller, paddles and turbines. So in case of a propeller, and there is one type that is known as pitch blade turbine. So these are the axial flow impellers. So that means the current produced like this. And there are another types like paddle, flat paddle, curved blade, disc flat turbines. These are the radial impellers. So we will discuss this part later. First, so propeller and pitch blade turbines are axial flow, and remaining, that is paddle, flat blade, curved blade, disc flat blade turbines are radial flow impellers. So in generally the axial flow impellers are used for at a high speed. It is used at a high speed, and it is also used at a low speed with the solid in suspension. Means if you want to mix the solid plus liquid, that at that time you have to keep the speed of that impeller at slow speed. And if you want to disperse, that means distribute any material, solid material in liquid, at that time you have to increase the speed of that impeller. Okay. And in case of radial flow impellers, if you want the large scale of mixing of solid and liquid, that means if you want large scale of solid material mixed with the liquid, at that time you have to use the radial flow impellers. So these are the applications of axial flow and radial flow impellers. So then first impeller is called a propeller. So propeller is nothing but it is a axial flow high speed impeller, and it is used for the low viscous liquid. Low viscous liquid means only like a liquid like water. So it is having low viscosity. It is a simple and portable. That means the construction of propeller we will discuss in the next lecture. But now you must keep in mind that these propellers are simple and portables, and the diameter of the propeller is in between 50 to 30% of the diameter of the vessel. Okay. So this is all about the propeller. So today's lecture I had discussed about what is the mixing, then homogeneous and heterogeneous mixtures, then what is the importance of mixing and agitation, then mixing liquids with liquids. So for that purpose agitated vessels are used. And in the last part we had discussed axial flow impellers and radial flow impellers. So remaining part we will discuss in the next lecture. Thank you.